All right, guys, we're getting down to the wire here. There's basically two things that I want to talk about with you still before the end of the year. Number one this week is inverse trig derivatives. And then number two next week, I want to talk about limits of trig functions a little bit. So when we start talking about our inverse trig derivatives, the first thing I want to mention is going to be just like last week when we did our regular trig derivatives, where it's going to be a set of, you can think of them almost as formulas. You just want to have these derivatives memorized and know how to use them. That's the shortcut. I'm going to say, just like last week, I'm really only concerned with you guys really knowing sine, cosine, and tangent. And I told you last week, those are the ones covered on the AP test, so those are the ones I focus on. I'm going to give you all six. You're going to see all six in the homework, but as far as for the future, make sure you have the first three down. And we're going to, just like we did on day one last week, we're going to apply our derivative rules, product rule, chain rule, quotient rule, things like that. So first of all, here are the first three. And I said these are the main ones. These are the ones you want to have memorized. These are the ones that you will be expected to know when you take the AP test next year. And each one is a formula. It's not like our trig derivatives last year or last week when the derivative of one gave you another. The derivative of sine is cosine. It's not like that. What we have is these formulas in terms of x. So you can take a look at them. One interesting thing to notice, the derivative for inverse sine and inverse cosine are exactly the same, except one of them is positive and one of them is negative. And then we also have the derivative of the inverse tangent of x, which is a little bit different from those two. All right, as I mentioned, I want to give you the other three. I said these are the others. I want you to see them. If you need to know them for the homework, there might be a couple homework questions that involve them. Just look them up. You don't need to have these memorized, but the first three I do. I want you to know. So, for our first homework question today, or first practice question example, we're going to do a chain rule question. And the reason I know it's a chain rule question is I look at it and I say, well, I already know how to do inverse tangent of x. That's the one we just learned. Now we have inverse tangent of something more complicated. That's when you do chain rule. So when I go to do the derivative, let's start with this. Let's go up to the side here, or up on the top here. And I'm just going to make a note of the derivative that I just gave you guys. The derivative of inverse tangent x is 1 over 1 plus x squared. Now, when I go to take the derivative down here, f prime of x, I'm going to use that as a formula. And remember, whatever I'm taking the inverse tangent of for the first part of my answer is going to basically go there for x. So the first part of my answer is going to be 1 over 1 plus that whole thing squared. But that's not the whole answer, because remember the chain rule says if you're doing the derivative like we are right now, chain rule, and you're substituting it in almost like a function, at the end you also have to multiply by the derivative of whatever that thing was. So I have to multiply by the derivative of 3x squared minus 7x plus 3, but that's a simple derivative, that's just power rule. So on the first one you multiply by 2, lower the exponent to 1, the derivative of negative 7x is negative 7, and the derivative of 3 is 0, so that'll just disappear. So basically it's 6x minus 7. And what I would do to finish cleaning up my answer, since we're multiplying, basically just take that and put it on top. Don't bother foiling out that thing on bottom. 6x minus 7 over 1 plus, just leave your answer like this. If you multiply it out, it's fine, but it's extra unnecessary time. This is perfectly good for an answer. So there's our problem right there. On the first half of the question right here, I'll box it up in green, that's where we are kind of applying our new formula like a derivative. And on the second part over here, this is the actual chain rule part. All right, let's do one more example and then we'll call it a day. So what we're going to do here is a quotient rule question. And again, I can tell right by looking at it, I have inverse sine of x over x, two separate functions, one over the other. So we're going to do quotient rule. So for this question, when I go to find f prime of x, let's set up for quotient rule, leave ourselves space all the way across. So for quotient rule, what you do is you square the bottom, that would be x squared, and then you have the derivative of the top, inverse sine of x. Now that's one of them that I just gave you. That's 1 over the square root of 1 minus x squared. And then times the bottom, which is x, minus the derivative of the bottom is just 1. Derivative of x is 1, times the top, which is inverse sine of x. And this is one of those where right now it looks kind of messy, like you have x over the square root of 1 minus x squared minus inverse sine of x all over x squared. And this is the point where technically that's the right answer. Like if this were a free response question on the AP test and you stopped right there and boxed it up, you would get full credit for that. But the way we look at this is in this type of question, we usually don't want to leave this here. We have what's called a complex fraction. We have a smaller fraction inside a bigger fraction, and it kind of makes things look messy. So if you wanted to really clean this up, although it's actually not even going to be much cleaner, but at least you won't have that complex fraction in there. What you could do is just take that fraction and multiply the top and bottom by that denominator you want to cancel out. So this is just a good reminder for you guys on how to clean up those complex fractions. Because see, on top, really what I'm doing is I'm distributing. And what happens when I distribute it for the first part, it's just going to cancel and just leave you with an x. On the second part, I'm just going to maybe put it on the end. Inverse sine x times the square root of 1 minus x squared. And on the bottom, just push it all together. X squared times the square root of 1 minus x squared. So that bottom one in blue really is probably the best answer, the simplified one. But remember, if you stop one step earlier than that, that's still technically the right answer.